Hello everyone and welcome to another one of our maths tutorial videos. Today we're going to look at C2 geometric sequences and series, which is not too bad a topic, but I'm going to look specifically at interest rates, which can confuse a lot of students, especially transferring the interest rate into a common ratio that we use in our formulae. Now with our other videos, just like the same, you can pause it, replay it and make notes as you go along. So I'm going to use a pretty general basic example just so you can get a feel for how interest rates are used. Let's say I've opened up a bank account and the bank tells me you have an interest rate of 5% each year, okay? And I'll go to the bank account and I've got £1,000. Not real life, I don't have £1,000, but in this scenario I do. And the bank says 5% interest rate, so each year my account is going to increase by 5%. So if you wanted to work out how much I would get after 1 year, you would just add 5% to this value. In terms of the actual maths behind it, you're going to add 5% to this. This is the same as doing 1,000 times 1.05. Because we know 5% is 0.05. So if I'm adding 0.05 to 100% of the value, it's the same as times by 1.05. This is the tricky bit and the bit you've got to really understand, being able to transfer from an interest rate into a ratio. I'll give you a couple more examples. If I had a 10% interest rate, I would then be timesing by 1.10. If it was 28%, it would be 1.28. And similarly, if I had 80%, it's going to be 1.80. Okay, make sure you're happy and you understand how to transfer from an interest rate into a common ratio. That's when you're increasing. But say you are decreasing. Let's say each year you are losing 10%. Then you would be timesing by 90% essentially. You'll be timesing by 0.9. Make sure you understand that, because you're losing 10% each year, you're going to times your value each year by 90%. Similarly, if I had minus 28%, I would be timesing it by 0.72. Okay? Because it's got to get smaller, and you've got to have a little bit of common sense here. If you're losing 28% each year, that value has got to be going down. So you wouldn't times it by anything greater than 1, because that would increase it. You want to be timesing it by a decimal or a fraction that's going to reduce it. Okay? And similarly, just to complete it, if I was losing 80% a year, basically going bankrupt, I would be timesing it by 0.2 each year. Okay? Make sure you can understand that before you move on to the next part. So, like I said, we've now got our common ratio. 5% to us is, we're going to times it, it's going to be our common ratio of 1.05. That's what R is to us. Okay? And the other things that we know that A is 1,000. That's my first term, that's what I'm opening my bank account with. We've said R is 1.05. Okay? And we can now set up to use any of the formulas we have got for geometric sequences and series. If, for example, I said I want to know how much will be in my bank account after 5 years, okay? Essentially, I want to know what the fifth term is going to be, so I'm going to use this formula. This formula tells me what each term is, okay? So I want to know the fifth term. And all I'm going to do is put my values into the formula. So A, we said was 1,000, R, we said was 1.05, and N, which is 5, but it's n minus 1, so it's going to be 4. Then it's just a calculator job. You just have to put that into your calculator. We're going to have 1,000 times 1.05 to the power of 4 gives me, and you can check it yourself, 1,215.51. So after 5 years, this will be how much is in my bank account. Okay? And it does make sense because it's increased. And you just got to check, does that make sense in real life? I started with £1,000, after 5 years with a 5% interest rate, yeah, that does kind of make sense. Okay? So that's that type of question. Another question you might get is they might ask you, so we'll stick with a similar scenario here. They might ask you, how many years is it going to take before your bank account goes above £3,000? Okay, let's say that. So how many years before we're greater than £3,000? We're trying to find the value of n that gives me greater than £3,000. I want to know which term that is. Alright? So we're going to set up our formula again. It's the same formula that we're going to use, but this time we don't know what n is. We've got to work that out. So let's say 3,000. Okay? We're going to try and work out the value of n that will give me 3,000. Okay? So we put it into our formula, a r n minus 1. So we've got a times r to the n minus 1. This is what I've got set up, and now I've got to solve it. First thing I'll do is I'll divide by 1,000 here. I've got 3 equals 1.05 to the n minus 1. And this is now going to draw on your knowledge from logarithms, which is another chapter in C2. To get rid of this power, to solve this, I've got to take logs base 10 of both sides. Now I haven't written base 10, but it's assumed as the standard logarithm. Okay? And think about your log laws now. What can I do with this power? I can move it to the front. So log 3 will equal n minus 1 of log 1.05. Now I can divide, because log 1.05 is just a number. All of this is to the base 10, remember. That will equal n minus 1. So if I put that in my calculator again, I've got log 3 over log 1.05, and it gives me a value of 22.5. Therefore, we can say n is going to equal 23.5. So what's happened here is we've worked out the value of n that gives me exactly £3,000. So halfway through my 23rd year, I would have earned exactly £3,000. But I want to know the full year where I will exceed. So which year will my bank account start with greater than £3,000? Well, that's going to be the 24th year. In the 24th year, I will have exceeded £3,000. At the start of my 23rd year, I won't have. But halfway through, it does. So at the start of the 24th year, that would be my answer. Okay? So that's how you tackle interest rates with sequences and series. Just be very careful transferring from the rate into the common ratio. The rest is all pretty standard. But you've got to know how to tackle logs and your log laws, because they appear very frequently in geometric sequences and series questions. Thanks for watching. Make sure you're happy with the content of today. Replay it as much as you like and make notes and practice a few past paper questions involving this type of question. Thanks for watching.